welcome to the Prevent Biometrics first podcast episode. My name is Logan Gillis, and I do sales over here at Prevent. And today I have a very special guest with me, our Chief Science Officer, Adam Bartsch. Adam, welcome to the podcast.
Thank you, Logan. It is quite an honor to be guest number one, the Prevent Biometrics inaugural podcast. Good on you for doing this. Let's go.
Yeah, thank you. And I'll preface it. I always like to manage expectations. This is actually my first time hosting a podcast, so if you're expecting, a professional production, maybe give me 4 episodes. But we're gonna give this a whirl. I thought it made sense to have you on today, Adam. You obviously long history with the company. If you don't mind, the viewers don't probably know who you are. At one point, I didn't know who you were. So if you give us a little background on you and where you're from.
Yeah, and I like how you set this up. We got to set the bar really, really low, so we can clear it. If we just clear it, it's still a success. But no. So I'm Adam Bartsch. I'm Chief Science Officer and Inventor at Prevent Biometrics. I'm an engineer. Have undergraduate master's degrees in mechanical engineering from Ohio State. PhD in mechanical and aerospace engineering from Case Western Reserve University in Cleveland. Also have a graduate minor in anatomy that I got at Ohio State. I'm a registered professional engineer in the state of Ohio. For those of you that don't know what that means, it's sort of like the engineering bar exam. Most people can get that done in 8 years. Took me about 13.
Wow.
So spent a lot of time doing a lot of math and a lot of tests that bring me to this moment in time. So for about the last 15 years, give or take, I've been heavily involved in trying to measure head impacts on living humans. And that's been a challenge historically, forever, especially dating back to the 1940s and 50s when folks in the U.S. military started with a keen interest in looking at head impact, looking at head accelerations, trying to understand the human tolerance so they could design things like ejection seats for pilots or seat belts for vehicles and helmets for folks that might get hit in the head. So certainly there's always been a desire to measure head accelerations and head motion and head impact. It's just been very difficult historically. There's a number of reasons for that. Early on is because the tech didn't really exist, wasn't small enough. People would do these experiments. If you fast forward to the 70s and 80s, people were actually taking American football players and putting retainers inside their mouths with all this telemetry and stuff with cables that went out, 30, 40 feet, and people would be drooling everywhere. When I got my start in head injury and head acceleration, it was between my master's and PhD. I worked for a couple of years at a company called SEA Limited. This was in the early 2000s. And that SEA is a really well-known forensic engineering company. So part of what I did there was supporting a senior engineer, trying to figure out how hard people got hit in the head, what direction, what location, et cetera. And then sometimes trying to recreate that to figure out what actually happened versus maybe what folks thought happened, whether they fell over a balcony, whether it was a football player, in a head-to-head collision. At that time, all we could do was make custom hardware in the same way they had done in the 70s, where, this god-awful contraption stuck on your teeth and drooling and spit everywhere. And you've got this giant, suitcase or refrigerator size signal conditioning box, et cetera. So, while I've been working for 15 years on head acceleration, I've been thinking about it for 20 plus. And at the time, 20 years ago, it was kind of a cool idea. Hey, maybe there's one PhD project on this in the whole universe. And it's kind of funny now. Let's fast forward to today. Now, Prevent Biometrics exists. We're selling thousands and thousands of these head impact monitoring mouthguard systems. We've expanded that tech into, not just civilian world, but military. We're selling on 6 continents. There's obviously a demand for this kind of data. And it's kind of cute today to think about me 20 some years ago as a graduate student, just thinking it was kind of a fun math problem to work on. So yeah, we've come quite a long ways in a couple of decades here.
I'd say so. And I think if there was anyone that was questioning at home who the smartest guy in the room is, we know that it is definitely you, Adam.
I
Without,
I, I want to record that, play it on repeat for my 4 kids that are home today with me.
awesome. So why engineering? Let's back up a little bit. I want the crowd to learn a little bit more about you. Why engineering for you? What made you
Yeah,
decide that? Was it a lifelong
yeah.
passion?
I mean, a great question. So on my end, my dad spent about 4 decades as an engineering professor at Cornell University in upstate New York. Um, my mom is a registered nurse. I have 3 brothers. At various points in times, we were all involved in a lot of sports, also a lot of science and math. Um, I was as a kid, as a 12-year-old, people called me ESPN boy because I spent so much time watching ESPN. Now I also did pretty good at school, and I was decent on the playing field. I mean, my sport was really soccer, but I did track and baseball. Um, Ironically enough, I didn't do football because I went out in 6th grade and I got spooked because there was too much running. So I did the weigh in. I got fitted for the pads and helmet, and then I saw these kids running around a track, and I said, "No, this isn't for me. It's too much running." Of course, I turned into soccer player. I would do track. I would do the 3,200 meters, which is insane. Like in high school, it's just the worst ever. Um,
You
to
know, I
stay in
just
shape
said
for
you were the
soccer.
smartest guy in the room, right? I just want to make
Nah,
sure
yeah,
we
yeah.
say that.
No, not at all.
Gave
So in
up
any event,
football for
always played a
soccer.
lot of sports. My brothers did as well. A couple of my older brothers, they're engineers. Younger brothers, the artists, but also very good at physics. So it was just kind of a natural thing. I actually had thought, before I went to school, before I went to undergrad, I said, I really think if I could do something where there was some intersection of math and sport, that would really be a good fit for me. And so I spent a number of years, like during my undergrad, during my master's, kind of ruling things out. So I spent a summer working at a steel foundry. I learned I didn't want to do that for a living as an engineer. I spent a summer working at a big three automobile manufacturer, doing some pretty cool stuff. Just wasn't the thing I was most interested in. And then I spent one summer working at basically an industrial design firm that actually they're the people that if you go and have an automatic paper towel in a bathroom, I kind of worked on that a little bit. Those things that are now everywhere, and I tell people this, and they just roll their eyes and go, "We do not care about that story at all." But I was there at that moment, when that happened. Um, but yeah, it said I'm not sure industrial design is really for me. So in the end, it took a while for me to understand, wow, this head impact thing could go somewhere in research. And then it wasn't until about 2016 or 2017 when I met up with the guys from Prevent, including Mike Sjogren, our current CEO, where I started to change my mindset from this is a fun math problem and engineering problem to this could be a solution. And what I would say is in my future life, if I'm able to, I would love, love, love to be able to talk to graduate students that do research and let them know it's one thing to study a problem and think that's cool. It's 1,000 times cooler to solve the problem. So understand your responsibility to the world, not just to do some cool stuff, but to really solve those problems. And I would say there's a lot of fields out there where people are doing really cool stuff, but then every day, I sort of look around and go, "Can we please cure cancer? Could we please develop a vaccine for this disease? Could we just let's get it done?" So a lot of the way that Prevent operates today is we're just trying to get it done because we provide a capability that seems to be pretty important to a lot of people for monitoring head impact dosing. So then doctors and clinicians can document the clinical response, dose and response. We have these things today for surgeons in the OR with radiation. They wear a dosimetry badge. When they have too much, they got to take a break. That's what's going to happen with blunt force impact for sure. And we're really just at the launch point of that.
Awesome, awesome. And you kind of touched on this earlier, but the prevent system is obviously in a mouth guard. Why'd you guys decide to do it with a mouth guard?
Yeah. So I mentioned earlier about the military start of investigating head impact, and really it goes back to this guy named Colonel John Paul Stapp. He's a medical doctor, the Air Force, and he did all sorts of experiments on himself out at Edwards Air Force Base. But dating back to that point, it was an interest in getting data, but getting accurate data. And while technology was hard for Colonel Stapp to just tuck everything in a mouth guard and put it on his teeth, he recognized the value of highly accurate data. The next 50 or so years were all geared towards really accurate data, which meant small experiments with living humans. It was very difficult because, like I said, you needed those little bite blocks. The engineers forever have known you can't get accurate data unless it's anchored to your skull. And the only practical way in a living human is to anchor it through the teeth, with some sort of oral appliance, mouth guard, mouthpiece, whatever you want to call it. Now, certainly, those engineers haven't always done a great job of telling the medical doctors that. So we've had some revolutionary tech, like in the early 2000s. We had Simbex, which is an engineering company in New Hampshire, and Rydell, which is an American football helmet company. They came together with some small business funding from the National Institutes of Health, and they created what was called the Head Impact Telemetry System, the HIT system. And so Rick Greenwald, who's a really well-respected engineer, Trey Crisco, again, well-respected engineering professor, along with Fat Eyed from Rydell, they created this helmet system, and they worked a lot with Virginia Tech University, people like Stefan Duma and Steve Rosen. And what they did was they really, level set the average of the head impacts that was happening. But one of the challenges with that system was it would take a tremendous amount, an impractical amount of video verification to suss out, was that an impact? Was it not? Was it just the face mask moving? Was it the head moving? Things that are really, really, really difficult to tell, especially at any scale. So they did the best of what they could. It was a revolutionary piece of tech when nothing else had existed. And they learned a lot about American football. Of course, there was always at the end of the papers, they're saying, gosh, we would love to look at non-helmeted sports. We'd love to look at women and females. And the engineers, of course, said, well, we could do it if we could affix it to the cranium, and the teeth is the best option to do it. Every engineer, that's been known forever, that is the way to do it. And so somewhere in there around 2010, 2012, I really got going in earnest at Cleveland Clinic working on this, developing prototypes, that had a cable sticking out and an on-off switch. And we would do small experiments on half a dozen people. There were others certainly looking at this. There were some companies. There are universities like Stanford and Wake Forest. There's our friends down at University of Virginia and BioCore that have done this type of work for the NFL, for the NCAA. But in reality, it was one thing to know how to get an accurate piece of data. So check the box, attach it to the teeth is the best, most practical way to do it. That's like 1/10 of 1% of the solution. So congratulations. You built a mouth guard with a sensor in it. You can attach it to the teeth. You can get an accurate reading in the lab. You got 0.1% finished. Beyond the accuracy piece is the other 99.9% of put it in a box, ship it to somebody who frankly doesn't know how to use it. Can they get trustworthy data? Could they take it on that day out onto the field and use it? And when they're using it, if they get a massive head impact, can you send that data immediately to somebody who's overseeing those folks and making sure if somebody takes a massive head impact that might not get flagged by a human, that the mouth guard can flag it, kind of send up the flare and say, hey, check it out. This is a check engine light, just went on. So accuracy is critical. Mouth guard's the only way to do it, but there's the whole other piece of this that as a research engineer, I didn't fully appreciate until I got to Prevent, working with, all the maniacs at Prevent, yourself included, to develop it really into a system.
Cool. Cool. So you kind of touched on this a little bit. It's interesting because in the U.S., I think even in all the conversations that I'm having with various schools and organizations, our mind naturally goes to helmet sports, right? But the reality is one of our biggest customers, World Rugby, is a non-helmet sport. Can you kind of talk about how the World Rugby deal came to be and how they're using the device?
Yeah, yeah, and I'll take a half a step back and say, in the United States, there is a lot of history here. I've kind of started with that whole historical thing going back to Colonel Stapp in the 50s. There's also a little bit of inertia of things that have been tried and not worked, where I think there's this rightfully there's a thought process here in the States of things that have tried and failed that I think that's just the way it is, that we are somewhere in there of when we talk to people in the States with this amazing capability, they're aware of there's 100 papers out there on PubMed on top of Wall Street Journal, New York Times, Washington Post articles that are based on data sets taken from devices like an instrumented helmet or a skin patch that really weren't designed for single head impact knowledge. They were designed for end of season, average everything together. But of course, the clinicians haven't known that. So studies come out talking about massive head impacts do not cause concussion. Little teeny impacts do cause concussion. No, it's not the big ones or the small ones. It's all of them. So it can be pretty confusing. World Rugby, you're right. They don't have a helmet. I'm not sure they've really looked that hard at that research because it's really not applicable to their space. But they sure as heck have not had that level of institutional inertia in their thought process. So for them, it was actually simpler. Now, they might not think so, but it was way easier mentally for a sport that doesn't have a helmet because what do you need? You need an accurate device. How do you prove that? You go into the lab and test it against a reference. How else do you prove that it's accurate? You go on the field and have somebody do video verification. If the device says it's an impact, does the video confirm it? If the device says it's huge, does the video confirm it? If the device says it's a knockout, does the video confirm it? Oh, by the way, is there anything in there that doesn't make sense? Well, then maybe you got to pause. You clear that hurdle, then you go to the practitioners. You go to the people, you put it in the box and ship it to them and say, hey, how well does this work for you? Is this easy? Do you understand it? Et cetera, et cetera. Once you clear all those bars, it's very straightforward. That's what World Rugby did. They created the first ever performance specification for this type of technology. And as of today, Prevent Biometrics, through a lot of hard work, we're the only people on the planet that meet that performance spec. And we have multiple versions of our product that have met that spec. That's an independent assessment of our ability to faithfully report head impacts, as well as those big ones, as well as the cumulative impacts over time. So rugby, for better, has not been kind of biased by earlier attempts that failed. Similar with Department of Defense, they just want something that works. So when you show people something that works and they're thinking about it, and their BS detector is pretty high, you can't cheat that. You have to just succeed or you have to get better. And we've been in a position where it's taken a lot of work, a lot of engineering, a lot of math, a lot of science, but also a lot of design, a lot of intestinal fortitude, a lot of people even just sitting down and analyzing hundreds and hundreds of hours of video before we were as good at measuring head impacts, where like today we don't need video to verify anything. So again, it takes a lot, and rugby was fortunate. It was really right place, right time. And also I think the last thing I'll say about World Rugby. I'm not in their shoes,
Yep.
but in my opinion, some of what I can see and hear publicly in the media or from sources like The Guardian or the Guardian of Australia, it sounds to me like what I heard 10 to 12 years ago with the National Football League here in the States. There's a lot of concern, rightfully, about people getting hit in the head. There's some amount of yelling and screaming about the people in charge should be doing something. Um, and then also there's occasionally some folks that are talking about either data or talking about risk that might be a little more inflammatory than it needs to be. But World Rugby's taken an amazing approach where they just said, we're going to follow the data wherever it goes. If the data says we need to change rules, we're going to do it. If the data says we're going to need to pull somebody off the field, we're going to do it. If the data tells us that, 1 year, 5 years, 10 years from now, there's needs to be some change, you need to retire. I mean, they're going to follow it wherever it goes. So it's really an objective process, despite potentially salacious headlines or just people who are just searching for more information and more answers about, how hard can I get hit and be fine. So it's really an interesting time and place and kind of in the universe of sport.
Absolutely. And it's been a process too, right? Like, I think it's important for the people to know at home too, like World Rugby, this isn't a 1 year thing or 6 month thing. This has been several years in the making. Am I right?
Yeah, absolutely. I mean, to get to this point today, I mean, in the research world, it's quick. I mean, it took them about 2.5 years. And to normal people, they would say, I don't know why it didn't take them 2.5 weeks, but their researchers are slow. I'm a recovering researcher myself. I mean, we would spend time kind of wasting time, honestly. I'm just going to keep it real. And we thought we were making progress, but really it wasn't at the rate it needed to be. They've gone lightning fast. I mean, really, they took them 2.5 years to go from zero, like literally zero data, to working with their partners to establishing what the concussion assessment threshold should be. And there's nobody that's looked deeper under the hood at that data, at the prevent data, than World Rugby. And there's nobody that is more correct about what they're doing than World Rugby because, they have all the information, they have all the right people analyzing it. It's all arm's length from the head parent entity. And so, in my opinion, they're making good decisions about, they set a threshold. They've started with setting a threshold that blends the need to find people who otherwise would not get assessed with the flow of the game. Now, if you're a purist, you would say, who cares about the flow of the game? Get everybody off the field if they're ever hit. That's not reality. The reality is occasionally people get hit very hard, and sometimes those people are never seen by the human eye. And the reason why is the head impact is 10 milliseconds. You blink your eyes, 200 milliseconds. 1/20th of an eye blink, the energy has gone from outside your skull to inside your skull. You can't see that no matter who you are. All you see, like these eye-in-the-sky spotters, great people, really experienced clinicians, they can't see everything either. And it's not their fault. It just happens so quickly. So basically, what World Rugby said is the data says, here's our limit, and here's the compromise of, we think if we did maybe one extra assessment per match, that's a good number to start with. And we reserve the right at any time to change this, make it more conservative, make it more liberal. But we need to actually implement, we need to train our clinicians, and then we will modify in year two, which is actually what's going on right now. Is they're getting through year one, and they're looking at modifying to make the game even safer on the backs of what they've learned and the data that's coming through. I mean, the other way to say it is, once you start this, I mean, it really is integral to the whole concussion care path. And Logan, I'll say one more thing and I'll pause. People need to understand, at least in the United States, I've talked to a lot of people who said, everybody's going to get pulled off the field all the time. No. And you know why? That's disingenuous. Because as a parent and as a sports fan, I coach sports, I played sports, I watch my kids play sports. If it really happened that people should be pulled off all the time, none of our kids, none of our friends, none of us would have ever played. We all know this is a rare thing, and we all know because it's so rare, it's not a big deal when you find somebody who might be hurt to get them looked after. I mean, this is no different than somebody, potentially hiding a meniscus tear who does a good job at not limping. And then once you figure it out, you get it treated. It's not everybody. It's like maybe 1 in 1,000 head impacts has this situation where you want to get them checked out. And I lied. There's one more thing with that. The faster you find somebody who is concussed, the faster you get them returned to the field at full health. This is data out of the University of Pittsburgh. If you get a concussion, and this is at all levels, and you continue playing for 15 minutes more, you will not get unconcussed doing that. But what you will do is double your recovery time. So on all levels, it just makes sense. It's just there's a challenge here in the United States because I think a lot of people have talked to me, they're just not able to like think about it in kind of a logical flow. They start to kind of get distracted by all these kind of ancillary, potential issues, which really aren't applicable. I mean, the bottom line is you measure a head impact. If it's a massive one, get the kid checked out. It's that simple.
Absolutely. Now, I want to switch gears a little bit here if we can. Obviously, World Rugby, major use case, but also a high standard by the U.S. Department of Defense. How are they using prevents technology?
Yeah, great question. So when I was at Cleveland Clinic, 2014, 2015, got awarded a cooperative development agreement with the U.S. Army. And at that time, it was to basically assist with trying to co-develop 100 prototypes that could be used in military applications. Well, of course, we had the help of, like I mentioned, Mike Sjogren and others raising money, developing tech as the research moved along. Prevent was really rampant to build the system. And so we ended up doing about 2,000 or 2,500 persons instead of the original 100. Same budget, same amount of time, which was good. I mean, it's beneficial to everybody and the taxpayer. Out of that, what happened was, for the first time ever, the U.S. Army has data on combatives, which is basically like boxing, MMA, judo. They do this almost everywhere. And we had data that said, well, geez, if you're at this one service academy doing physical education combatives versus this other one, well, one of them looks like they might be giving people kind of massive head impacts. And the other one is almost like my kids in a pillow fight, which is good because you don't want to hurt people in training if you don't have to. We also did parachuting. No surprise, the parachutes that you can steer, when they land, it's like nothing. It's like 5Gs, my kid's on a trampoline. The parachutes that you cannot steer, which is if we need to go invade somewhere and take out some bad guys, you drop thousands of people. You can't have them steering because they'll run into each other. So you just drop them all. Well, those ones actually have some pretty rough landings. And they may have way more rough landings than we are all aware of, because once you start monitoring the head impacts, you find out a lot of these folks, when they hit really hard, they just suck it up. They just tough it out. They get on the bus and they go home. They don't tell anybody for 20 years. Then they go to the VA, the Veterans Affairs system, and they say, here's all the times I got a concussion. And the VA says, we believe you, but we can't give you any disability rating because we have no record of that ever happening. So on a number of fronts, just documenting the data has been massive. So that work that was funded in, 2014, 2015 has now led to this year, we're doing 2 studies with 2,000 total paratroopers with the 82nd Airborne. We're not just building mouth guards and measuring head impacts. We're measuring head impacts, and then the big ones are getting immediately referred to a doctor. And then that doctor is doing all of the important assessments, eye tracking, pupillometry, there's a spit test in there, blood draw, balance test, cognitive test, immediately. In the history of medical science, this has never happened because nobody ever had a way to figure out who got hit hard. And also, In the Defense Department, there's a lot of training environments where the risk of hitting your head hard might not be that high, but because of how many people go through the training, it's really kind of a target rich environment for research. And even better, if you could find these people quicker, you'll get them, mission ready quicker, because these are folks that need to be ready at any minute to get on a plane to go, defend freedom and, free the oppressed around the world. So the DoD has a keen interest. They've had programs going on for more than a decade trying to identify a sensor that could monitor a head impact. Here we are. I think what's going to happen with the DoD, they're already in touch with World Rugby. It would be kind of obvious that those two entities will be communicating with each other. And I suspect World Rugby will be assisting or setting the precedent for the Defense Department to work on what's called a requirement, which basically says, here's a device, here's what it does, here's how good it has to be, here's how it has to work in our concept of operations. I mean, that is underway. That might take a little bit of time, but again, worlds colliding. Rugby goes first. Defense Department says we've had this similar challenge. Hey, can we learn from you? And maybe we can then set a standard on that as well. You better believe as soon as the United States Defense Department does that, every other contact sport in North America, if they haven't done it already, will really need to get their act together, because then it's going to be tough to justify that it's come domestically, and we've still got maybe contact sports not necessarily taking the lead on health and safety of a very simple thing and a mature technology that can be helpful.
Right, and I think you almost beat me to my next question here.
Okay.
Which was what's next for Prevent, right? What's on the horizon for Prevent? Obviously, you've dealt with World Rugby, you've dealt with football organizations, you've dealt with the Department of Defense. There's obviously tremendous amount of validity to the device. It's accurate. Where do we go from here?
Yeah, that's again, great question, Logan. You've done your homework. I mean, in my opinion, there's a couple of things. Just real quick on the Defense Department, there's some exciting developments there, not necessarily for blunt force athletes playing football, lacrosse, ice hockey, but more so for our warfighters and our allies. And that's around not just measuring head impacts for blunt force, but measuring blast overpressure in a training environment. Anybody that watches the news or reads the papers online, usually what happens is the concussion problem for the military gets wrapped up together. And while blunt force is the main source of concussion in the military, it's actually the blast waves that get a lot of publicity, and even recently in congressional hearings. So we're working on some tech that might be pretty beneficial that is also tied into our back end system. So again, building a gadget, 0.1% of the solution. Building a system with good data around that gadget, that's the 100% solution. So that's moving, and I'm pretty excited about where that's going, both in the States and some other countries. But if you take it back to the United States or North America, I mean, I think, again, it's going to take a little bit of time, but I believe slowly but surely, Prevent and our collaborators, whether it's these leading research institutions that have spent years working with us and us with them, or whether it's entities who are really the leaders in the field, even if they don't own the entire sport. But if you look out at somebody like, logically, the National Football League, the Canadian Football League, the National Hockey League, the various professional lacrosse leagues, heck, Major League Rugby is the first professional sport in North America to have this paradigm shifting capability for concussion assessment, identification, and treatment in their head injury assessment process. So slowly but surely, as folks become aware of what is happening overseas and in the military, I believe the leaders in those fields, these are the medical folks who are advising these premier leagues with premier players, premier salaries, premier value, are placing that value on brain health, and they will see that this is a pretty straightforward solution, maybe not to implement day one in the pros, but possibly support something at the lower levels. World Rugby did the exact same thing. I said it took them 2.5 years. So if I think about, I don't know if it's the NHL or the NFL, two and a half. If they started today, they could say, look, we're going to take 1,000 people between 10 and 18 years of age, and we're gonna follow the World Rugby model, but also we have our own particular questions. Like maybe in ice hockey, there's a question about how do you prevent boarding, or maybe there's a question about how do you make a better helmet when the helmet hits the ice. So there's going to be some specific questions for that sport. You don't need pros to answer that. But I think what should happen here is we'll get gradual take up, just organically, um, in those leagues where they'll talk about don't start at the highest of the high level because there's all problems there and political issues, but take credit for doing sort of the World Rugby approach. Start lower, answer some basic questions, move up another level, and then eventually you get to the pros. And that's my welcoming committee barking in
That's
the
your
background.
alarm right there. So no worries. Well, Adam, I really want to thank you for your time today. This was incredibly helpful, incredibly informative. I know I learned a few things, and we look forward to catching up with you again sometime soon. But to all our viewers out there, thank you for joining us for our first podcast, and we look forward to seeing you soon. Thanks.